Hello, this is my video for physical and creative computing, where I'll be going through my influences, design, and evaluation for my wireless sampler piece that I created. Going straight into my influences is where I looked over at my OSD device and I was like, I'm going to use this probably to influence and update an old instrument or musical equipment instead of creating a visual kind of synthesizer, because I prefer physical instruments. I quite like DJing and stuff like that. So let me just play this short little clip. So you can see there was a cello or another string instrument, which I might not know the name of if it's not cello, and there is a device attached to it with obviously sliders, which I assume are affecting some properties of the sound, such as the pitch and the pluck, but it also seems like it's carrying on the vibration from the struck instrument. So instead of it just dying after a pluck, it's keeping the momentum of the sound going, which is probably due to some vibrations here at the bottom of the instrument. But I found this really interesting and it definitely gave me some ideas. The next thing I found was this is some sediment which has been developed onto film. And that has been done by having a sediment the sediment of a riverbed in a jar, and then film has been put into the jar, or I think film was put into the riverbed, either one. And then the film has been run through a device, which is then getting read by this patcher. But on the film, there's a optical sound kind of film part of the film where it takes in sound. So you are literally hearing earlier on a second ago, you can hear the river. That is the sound of the river, and I just found that really inspiring. And this is really what pushed me into my next thought, which was a old school video of Kanye West performing "Runaway," all rights reserved to Kanye West and his record label, and obviously the performance. And that is him using that Kaya MPC 2000 to really bring a level of performance up a tier from obviously just stopping the sound. And that gave me a few ideas for my piece. So I wanted to create a downscaled version of this, but also bring something new. And what I wanted to do with the new aspect was bring in some chop and screw aspects, which was a DJ kind of technique, DJ technique, obviously, by the guy called DJ Screw. He was from Texas. That's where the sound originated from, obviously, because that's where he's from. And he basically chopped up songs, just chopping them up, but it sounded really good. It was always on beat. So I went ahead and tried creating that in amongst with my APC prototype wireless sampler kind of inspiration. So here you can see my blue button is where the chop and screw aspect plays into it, which will go to the first beat of any bar in the song randomly, and then the rest of the buttons are all sample loops that you can put in any sounds. You can put any sounds into all of these. These are all interchangeable. And now this is where the music theory I had to look into to obviously create that chop and screw aspect, because I needed to figure out how many milliseconds each thing was to put that into the OS into the max patch, because it didn't work on BPM, it worked into the milliseconds. So I had to figure out how many, just like understand the method behind it. So I just did loads of equations for different BPM. So this one's 180 BPM. This one's 60 BPM, and to obviously work it out, you need to divide it by 60, because that's how many seconds there are, or 60,000 if you're doing milliseconds. And I just really gave me a new level of understanding. And then I'll quickly go into the device, which is being played by the Bristol DJ, Sir Hiss, because obviously he's been around musical equipment. There's no one else I could have asked better to try out my device. And going on from that, you can see this is the wireless aspect of it. He's spinning, no wires attached. And I just wanted to go through from some evaluation issues, not issues, just things that I had to go over through. And that was obviously one of the most hardest, was being the transport functions and understanding the theory behind that and how I could get that to work. Because for ages I had the transpose, where I showed you the equation earlier, from 60,000 I had it at 100. And then I was like, what am I actually trying to do here? And I broke it down, and then I figured out that I needed 60,000 because I was working in milliseconds. And once I did that, it went to the first beat of any bar that you put in, and it really was just satisfying to use. Like one other thing that I would quickly add on is, if I could have just made it much better, much cleaner for the user to use, would just have a little case. But with that said, I did get information back saying that it wasn't, the wires weren't in the way, and which is really important when you have a device like this. And I know I'm pushing on a little bit longer than I was meant to, so I'm ending this right now. Thank you for watching this. Yeah.